Welcome back. We're now on lesson 9A, depreciation. Depreciation is normally thought of as the decrease in value of an asset. Add this to your list of vocabulary. Accountants use depreciation to allocate the cost of a tangible asset over its useful life. Think about the research you did for the preview assignment. Name some assets that might depreciate. Why would a business want to allocate the cost of a tangible asset over its useful life? And then name some assets that might appreciate. Go ahead and hit pause, write down some thoughts for these answers, and then come back and we'll answer some stuff together. Some things you might have put on part A: automobiles, cell phones, computers, washing machines. Some answers you might have put on part B: depreciation is an expense that may decrease the tax burden by decreasing net income. Part C, you might have put stuff like real estate, jewelry, gold, rare coins, paintings. In this lesson, we will understand that finding the output value from a graph of a model given an input value is an estimate. When given a symbolic model, the exact value of one variable can be obtained given the value of the other variable. When we're done, we're going to be able to interpolate. You want to write that one down. Extrapolate, write that one down too, using graphical representation of the relationship between two variables. And finally, we'll use a symbolic model to find the exact value of one variable given the value of another variable and relate those variables or values to the context of the problem. The IRS defines depreciation as an annual allowance for the wear and tear, deterioration, or obsolescence of property. Depreciation becomes an income tax deduction that allows taxpayers to recover the cost of other basis of certain property. Saying again, it allows taxpayers to recover the cost or other basis of certain property. Part 2, or question 2, is a great place for you to hit pause, work on question 2, all of its parts, or at least get started marking up what you see on the graph, thinking through it, and then coming back and letting us work on it together. A landscaping company purchased a 54-inch 530cc floating deck lawn mower for $5,450. The graph illustrates the relationship between the years since the purchase and the depreciated value of the mower. We have value, we have years. Notice that 3 points are collinear. And I hope you're writing all of this information down and hitting pause to do so. So it says on here, and I need to stay with what the questions are asking on part A, estimate the value of the mower at year 3. And if you're looking at this as a line, year 3 is about right here, and it's about right here. And based on how you draw the line, we're still going to be getting around, probably around $3,500 or somewhere in that neighborhood for an estimate for part A. Do start and stop this part B, as we answer these to make sure that you've got the vocabulary written down and a definition and even an example using the one that we're talking through. The company determined that this asset should be depreciated. I need my words to come out here. The company determined that this asset should be depreciated for 7 years using the straight line depreciation method. It means that the depreciation is the same amount each year. Big deal. And there's a salvage value of $1,250. In the previous assignment, you were asked to find definitions of some of these items. Using those definitions and the information we just read, determine the following as it applies to the lawnmower. Make sure you've already attempted these before you listen to the video and we work through them together. What is the basis of the mower? The basis of the mower comes from part A, and it's where we start. It's the price that we paid for the lawnmower. What is the class life? Class life comes from this problem, 7 years. Salvage value, they gave it to us in this problem. It's $1,250. And then the depreciable basis. The depreciable basis is taking the basis and subtracting the salvage. Here's basis, here's salvage. When we take basis minus salvage, I'm getting $4,200. Then what is the depreciation for the first year? Round to the nearest dollar if necessary. We're going to take the depreciable basis and divide it by the number of years of depreciation. So our depreciable basis was $4,200. 7 years are the number of years. When we divide out, we get that our depreciation for the first year is going to be $600 for every year. This is a good time to hit pause again and complete part C by yourself, as well as question 3 and question 4. At least go ahead and do part C and then come back and let's do it together. We calculated on part B that the depreciation for the first year is $600. So looking at this chart, it asks us to complete the table using the graph and the depreciation information we just looked at. So $5,450 is the starting value. If I subtract $600, that puts us at $4,850. And then it jumps to year 5. It's going to talk about interpolation. It's going to talk about year 3. It's going to talk about year 2, year 4, and I'm going to end up putting year 6 and year 7 on here. So we can do all sorts of stuff with the information we have. We can create an equation. We can play around with our calculator. So I'm going to go ahead and get another graph started over here because they just have a whole lot of information that's being asked for. Years and value. So if we are looking at years 2, 3, and 4, I'm just going to keep going with what we are, as it was said on part 5 of part B, the depreciation for the first year, and it's actually going to be the depreciation for every year. So I've already calculated what it would be now that we're at year 1, but we can take year 1 and go down $600 more, and that would put us over here at year 2, which would be $4,250. We can go down $600 more, and at year 3, it puts us at $3,650. Hang on just a minute. We just guessed a while ago and guessed around $3,500. We did a great job. I'm going to keep going and subtract $600 again. And now we're at year 4 with $3,050. And let's subtract $600 again. And that'll bring us back over to this chart at year 5. I'm going to stop for just a second on all my subtracting. And I need you to write down this word, interpolation. Since year 3 is between the data that we were given year 0, we were given year 5, I believe. Yes, year 5 is on the graph that we saw earlier. It's not exact, and they did not tell us that exact number. But what it's saying is from our given data, since we were given year 0 and year 5, we're going to use interpolation when we find the value of year 3 because it's between given information. You think it's going to be appropriate to use interpolation to find the value of the mower at year 2 or year 4? And yes, The linear nature of this type of depreciation makes finding these values just as accurate as finding the value for year 3. These are between years 0 and year 5. If you haven't done questions 4 and 5, this is the time to hit pause and go ahead and do those. And I'm going to keep doing questions 4 and 5 on this screen, starting with year 6. So looking at year 6, I'm going to take year 5's value, go down $600 more, and now I'm at $1,850. I'm going to go ahead and go to year 7 because it's talking about, well, somewhere it did. Hang on. Go back to question 4. Use the graph and or previous information to estimate the value for year 6. And we can estimate looking at the chart, and I'll go ahead and find that one. So looking at year 6 to estimate on the chart, if we are here, we're about here, which we're almost to $2,000. So almost $2,000, write something down. 1,900, 1,800. And then looking back at where I kept going backwards by $600, we ended up at $1,850, which is almost $2,000. So question 4 says use the graph and or previous information. So on the graph, we got, somewhere up there close to $2,000. That's reasonable. And then by using our numbers, we got $1,850. Moving on to question 5, it says finding a new data point beyond the original observation interval is called extrapolation. Make sure you're writing that word down also. Since year 6 is beyond the interval that we have here from 0 to 5, we're going to call this one extrapolation. And question 5 then goes on to say, do you think it's going to be appropriate to use extrapolation to find the value of the mower at year 9 or year 10? And then it says explain parentheses. Watch out, it's a trick question. And so year 7 has significance with the original information they gave us because we're going to only own this thing through year 7. So on question 5, to go look at question 9 or 10, could we use extrapolation? No. Even though the depreciation would continue to be linear, our depreciation for this question ends at year 7. So even though the line could extend to years 9 and 10, these are beyond the domain of this relationship since the class life is only 7 years. One of the really cool things about math is that we can display our information in a myriad of ways. Question 6 says, an algebraic model. We may be able to display it, but I'm not able to write it. Here we go. Part 6, question 6 says an algebraic model can be created to symbolically express the relationship between the age of the mower in years, which is the input, and the value, which is the output. And so if we look here, and I love using words, the value starts at $5,450. That is actually the B, the y-intercept. And we're going to go down $600 for every year that we have this item, this mower. And so to put y is a little confusing, so I'm going to use T for time, meaning the years. And you've seen this before as y equals mx plus b. This one's just written a little differently, that we put b first because our slope is negative. So it's just the intercept minus the slope times the years. This is symbolic. It's an algebraic equation. It then asks us to use the algebraic model to find the value of the mower at the end of 4 years. So we're going to say our value is worth $5,450 minus 600 times 4. I know we've already looked at this using the chart and playing around with the minus 600, but this one is a bit faster, where we can take 600 times 4, and it's actually 600 hit negative times 4, and we get the value, and I'm going to go up here, $5,450 minus $2,400. And you need to play around with your calculator and your understanding of integers, I'm going to add in $5,550, and that puts us at a value of $3,050 at year 4. I bring our chart back and then point out our calculation using mathematics. We found the same value of $3,050 at year 4. I also bring our graph back because at year 4, and I'll change that color, at year 4, we're right here. It looks like we're exactly on 3,000. Remember, I said it's going to depend on how you draw the graph, and if I'd drawn it just a little bit higher, it would have been a little bit above the 3,000 line at our 3,050. It's really cool that there are multiple ways to display the information. Going back to question 6, part B asks if it's interpolation or extrapolation. It's within our original data points, so it's interpolation. Use the algebraic model to find the value of the mower at the end of 7 years. If you have not already hit pause, this is a great time to hit pause and you calculate B, C, D, and E. The value, beginning with our $5,450 minus 600 times 7, again, I will punch in on my calculator 600, but call it negative, and change it over to negative, times 7, I get an equals, and so I'm looking at $5,450 minus $4,200, and I'm actually going to add in $5,450, and I'm looking at the number of $1,250. And if you go back and look at question number 2, part B, section little 3, Roman numeral 3, it asks what's the salvage value? And the salvage value after 7 years is this number that we have gotten using a chart, a table, or using our algebraic model. Part C says, wow, I just did part C up there on part B. So part D says, is this interpolation or extrapolation? And since it's outside our original data values, it's extrapolation. Part E asks us a little bit of a different question, but that's okay. We can look at it and we can play around with what they're asking, because now it says how long. Okay, wait, how long is time? So how long are we going to keep this mower before the mower's depreciated value is $2,300? So I'm going to write our entire algebraic formula here. And this time it wants to know if the value is 2,300 with all of the other parts of our equation, it wants to know how long. When is the time going to be, or what is the time going to be when our value is at $2,300? So some simple, nice, non-scary algebra. Let's subtract the the y-intercept and grabbing my calculator, I'm at 2,300 minus 5,450, and I get negative $3,150 is the same as negative 600 times t. To finish off this equation, to find out what my t's value is, I'm going to divide both sides by negative 600, and when I am done, I will have my value of t. This information over here becomes a positive 1, so I'm punching in 3,115, which is negative, and dividing it by 600, which is negative, and I get 5.25. Since this is how long, we would make it to this value of $2,300 in 5 1/4 or 5.25 years. There is one more question in this lesson, and I'll leave that for you to look at. What we have done is sufficient with the table, the graph, the algebraic equation to more than supply the information that you need for the practice assignment. But it is interesting how they keep going and they rewrite information, and it makes you faster. I'm not going to explain it. You can surely go look at it, and it might be something you want to incorporate in your learning and in your practice to make you a little faster on the equations. But what we've done up to this point is plenty for your homework and plenty for test number 2. This finishes lesson number 9A. You need to look at your syllabus to see if there are more lessons that are due this week. If there are, keep going. If there are not, definitely do the homework. And we're getting ready for a test very soon, so start prepping for test number 2.